Alright guys, today's goal, 6.6. The learner will understand de Moivres theorem and nth roots. Okay, the complex plane, trigonometric form of complex numbers, multiplication and division of complex numbers, power of complex numbers, and roots of complex numbers. Okay, and why? The material extends your equation solving technique to include equations of the form z to the n equals c. N is any integer and c is a complex number. Alright, so let's take a look at what we're going to be doing. So, complex plane, real number, imaginary number. Real number is the x, imaginary number is the y. So if you have 2 plus 3i, you move 1, 2 to the right, 1, 2, 3 up. Okay? Okay. Absolute value modulus of complex numbers. The absolute value or modulus of a complex number, z equals a plus bi. Well, the absolute value of z is the absolute value of a plus bi, which is square root of a squared plus b squared, which we've seen. Okay? In the complex plane, a plus bi is the distance of a plus the distance of bi from the origin. Okay? So if we look, it is talking about this distance. Well, another way we can look at this is a is equal to r cosine theta, b is equal to r sine theta, because this way we can write it in vector form. Okay? So, trigonometric form of a complex number. The trigonometric form of the complex number, z equals a plus bi, is z equals r times the quantity cosine theta plus I sine theta, where a is r cosine theta, b is r sine theta, and r equals the square root of a squared plus b squared. And tangent is b divided by a. So the number r is the absolute value or modulus of z, and theta is an argument of z. Okay? So let's take a look at a problem now. It says find the trigonometric form of 0 is less than or equal to theta less than 2 pi for the complex number 1 plus 3i. Okay? Well, I know I can get, so we need to make this look like that, okay? Or we could just do z equals r cosine theta plus I sine theta. So then r equals square root of 1 squared plus square root of 3 squared, which is 2. So then you get z equals, well, before we do that, we got to go tangent. Theta is the inverse tangent of square root of 3, which from the unit circle, you should remember that's pi over 3. So then we get z equals 2 cosine pi over 3 plus I sine pi over 3. So there's the trigonometric form. If they wanted the standard form, you'd just take the cosine of pi over 3. So cosine of pi over 3 is 1/2 times 2 is 1. Sine of pi over 3 is square root 3 over 2. So it'd be I square root 3, which, see, that's what we got. Okay? Moving on. Okay, so product and quotient of complex numbers. Let z equal r cosine r sine plus I sine. Let z2 equal r2 cosine theta 2 plus I sine theta 2. Then, to do multiplication, you multiply the r's, add the angles. To do division, you divide the r's, subtract the angles. Okay? And yes, the r2 cannot be 0. Okay, so there's some more properties. So, express the product of Z1 and Z2 in standard form. Okay? So, you have 4 square root 2 times the cosine pi over 4 plus pi over 6 plus I sine pi over 4 plus pi over 6. And that would be 4 square root 2 cosine 5 pi over 12 plus I sine 5 pi over 12. Now those ones you don't know, so and it said standard form, so that means calculate these. So this, if you do 4 square root 2 times cosine of 5 pi over 12, you get 1.464 plus 5.464 I. Okay? So there we go. Let's take a look at another problem. Alright, de Moivres theorem. Let z equal r cosine theta plus I sine theta. Let n be a positive integer. Then z to the n equals r cosine theta plus I sine theta to the n. Okay? Which is r to the n cosine n theta plus I sine n theta. So, if you think about this, it says use de Moivres theorem. So, let's find our z. So z equals the square root of 1 squared plus square root of 3 squared, which is 2. And theta is the inverse tangent square root of 3, which is pi over 3. So if we look at this, we have z to the 4th equals two to the 4th cosine of 4 pi over 3 plus I sine of 4 pi over 3. And then if we keep going into standard form here, you would get z equals let's see, 2 to the 4th, 16. Cosine of 4 pi over 3 is negative 1/2 plus I times sine of 5 pi over 3, negative square root 3 over 2. So you'd get z equals negative 8 minus 8 square root 3 I. Okay, let's look at another one. If z equals r cosine theta plus I sine theta, then n is a distinct complex number. So the square root, the nth root of r, is cosine of theta plus 2 pi k divided by n, and the I sine theta 2 pi k divided by n, where k is 0, 1, 2, 10 minus 1 are the complex nth roots. So find the cube roots of 1. So you have to think about this number as z being 1 plus 0i. So r equals 1. Theta is the inverse tangent of 0, which is 0. Okay. So you would say cube root of 1 times cosine of 0 plus 2 pi k divided by 3 plus I sine of 0 plus 2 pi k divided by 3. Okay, so what we need to do now, because it is cube root, that means you need to find k equals 0, 1, and 2, because it said n minus 1. So 3 minus 1 is 2, so you need to go watch. z1 equals cosine of 2 pi times 0 divided by 3 plus I sine 2 pi times 0 divided by 3. So z1 equals, well, what's the cosine of 0? 1. What's the sine of 0? 0. So it's just 1. So then you go z2 equals cosine 2 pi divided by 3 plus I sine 2 pi divided by 3. So z2 would equal, we'll just keep it going, negative 1/2 plus I times square root 3 over 2. And you get z3 equals cosine 2 pi times 2 over 3 plus I sine 2 pi times 2 over 3. So you have to think, what's the cosine of 4 pi over 3? Well, negative 1/2. What is the sine? And then the sine of 4 pi over 3 is negative I square root 3 over 2. Okay? So there we go. See you guys tomorrow.